Hi, today's video will be the first in a series of videos on aromatic compounds. So this video will be an introduction to them and then how to name aromatic compounds. So aromatic compounds exhibit conjugated pi systems enclosed in a ring. So I'm going to put down here just a few examples of aromatic compounds. So the simplest one, and many aromatic compounds are derivatives of it, is benzene. You can also have aromatic compounds that consist of more than one ring. So two benzene rings fused together is another aromatic compound. Naphthalene. You can also have different substituents on the benzene ring. So phenol, this is another aromatic compound. Now what makes aromatic compounds special is that their conjugated pi system makes them very stable. So some reactions that would happen with, say, just an alkene won't once you have an aromatic compound. So for example, if I just have cyclohexene and I react it in a bromination reaction, I'll get addition to the double bond to form one compound and is an enantiomer. But if I were to try the same reaction, only difference now being it's benzene, no reaction. And this stability is due to the extensive delocalization you get in the benzene ring. Right? It spreads out the electron density. So that's what makes these aromatic compounds unique and special, is their extensive delocalization and conjugation. Now in terms of naming these, there's three basic categories of aromatic compounds we'll have. One is going to be monosubstituted derivatives of benzene. So some of these monosubstituted derivatives have special names that we'll give them. So a common one, where you have a methyl group substituted, this is toluene. But you could also call this methylbenzene. Right? Either would be okay. If I have, say, iodide as a substituent, I would say iodobenzene. I don't need to give a location here because it's just one substitution, so that automatically is assumed to be position 1 because we don't have any other substituents. I can also have an alkyl substituent, so this would be propylbenzene. Now one note, if the substituent is longer in carbons than the number of carbons in the ring, so for benzene ring we got 6 carbons. So if we have a substituent that's 7 or more carbons, the benzene ring becomes the substituent when we name it. So say we have a benzene ring with octane as a substituent. this would be phenyloctane. So benzene, when it's a substituent, you use phenyl as the way to call it, whereas when it has substituents on it, you say benzene. So just something to note with the nomenclature there. Number 2, this would be now disubstituted derivatives. So when you have disubstituted derivatives, there's a couple ways you can name them. So I'm going to put a generic benzene here with an R group on it. There's 3 different positions on a benzene ring. Those are the 3 positions. The red position, this is called ortho. So if it's to either side of your substituent, that's called ortho. If you're 2 away from the substituent, that is meta. And then 3 away is the para position. So if I have this compound, said on the last page, right, this is known as, it's toluene when it has 1 methyl group. So when I name this now, there's 2 ways I could do it. I could say 3-chloro-toluene. I could also call it meta-chloro-toluene because it's in the meta position from that methyl group. Right, I could also name it like I would any, alkane and say methyl as a substituent and chloro as a substituent and give the numbers for each of those locations. Right, so really 3 different ways I could do that. Right, so if I did it that way, it would be 3-chloro-methylbenzene. Right, that's another way I could do it. So the last class then is going to be polysubstituted derivatives. Of benzene. So now this is 3 or more substituents. Once you get to polysubstituted, there's no, para, ortho, meta positions. Because then you don't know, okay, if it's para to one of them, what is it to the other? Like, which one are you referring to for each position? So it doesn't really work. So think about with these, all you're going to do is name them just like you would an alkane or an alcohol, an alkene. So say I have this compound, hydroxyl group and 2 bromides. I would name this, well, first I'd have to number, right? So 1, 2, 3, 4, 5, 6, right? The alcohol has priority over the halogen. So this compound would be 3,5-dibromo-phenol, right? That's one way I could call it. I could also call this 3,5-dibromo-1-hydroxy benzene. That's another way I could name it. So I have a methyl and an ethyl group. And then a third group of chlorine down here. When I name this in priority, this would be 1, 2, 3, 4, 5, and 6. So it would be in alphabetical order 5 chloro, 1 ethyl, 3 methyl, benzene, since I have to put the substituents in alphabetical order when I name it. So that is how you go about naming these benzene aromatic derivatives. Now, you will see in future videos we can have aromatic compounds that aren't benzenes, so we'll talk more about that once we move on to those compounds.